Yeah, here we are. So I see that the streaming is running. Let me open the camera, remove my Telegram, check from here, just a second. We will be live in 1 sec. Delete this, and I don't need to open Pro Tools. It's a habit. My VPN is off, everything is cool. I got my lecture here. Let's load it and let's go. Lectures. I'm really sad that I'm not delivering this lecture in person, to be honest with you. Like, I really wanted to deliver in person. Yeah, but well, this is happening, so let's go. Развитие, развитие, here it is. And dynamic range control. Okay. So let me put in the YouTube world. Let me switch on my screen. Here we go. Sanchez, Bratanis, hello. Okay, friends, so yes, we will have our final hello, man. We will have our final official conversation about compression that we will have. Oh no, another lecture about compression. Oh my god. Well, the thing is that I don't think that there are enough lectures about compression. I don't think that nobody understands compression, to be honest. And when I mean nobody, I don't mean nobody in the world. I mean nobody in our school or in our, maybe many of our teachers don't understand compression. And this is really the final stop on our relationship of the развитие технического слуха. Now Lisa is writing something about the showcase. It's a little bit late in our conversation because I already moved on from that topic. Let's please discuss that at the Elna, because if not, we will be the whole lecture talking about this. Look, I don't know where you took this idea that it should happen in the middle of July. There was never like a decision or a date or something. Nowhere. Like on any calendar, there was never like a. If this existed, if somebody put it, yeah, I get it. But did you have like Masha and Leo? It's like, I mean, these are different hierarchies in the project. I understand. Like, okay, I'm gonna restate this this answer. Let me say an answer that is more constructive than that one. I may be mistaken. Let's clear this out together. At the moment, we can say middle of July. Really, it's okay. It's okay. Excuse me for that answer. It's just like I don't like when the school acts in this coordination, and I get frustrated. But you're great. It's great what you told me. It's like, hey, this is not a problem, and you're right. So let me restate that answer in a better way. We either are going to have a small show or a big show. When that small show is going to happen, it can be in the middle of July. That's the best answer. That's the correct answer, better said. It can be in the middle of July. No problem. I don't care. I prefer that you guys play in the big festival so you get the big festival experience. If that's not possible, that's not possible. Not a problem. We will do it next year with better planning. At the moment, the approach will be about, hey, do you want to do small show or big show? And then what's the date and stuff, we will close it better. So sorry that I gave you guys a very shitty answer there. Thank you for pointing out, both of you, Lisa and Viera, about this. I'm sure that we will find a great solution and that we will have a great time. Like, this is something that I'm really sure. So, okay, so back to the lecture. Yeah, sorry that sometimes I become a little asshole. It's a bit of an annoying thing, but I guess that there is no way to live this life without being an asshole for 5 minutes. The important thing is to only remain an asshole for 5 minutes and not to extend it longer than 5 minutes. So, okay, guys, look, as I told you, this is going to be our last stop in our conversations about dynamic range manipulation. Why I decided to do this, because I told you as we were moving along, I told you like, hey, I really want to grab the book, and the book of Jason Corey, and I want to sort of see what he tells us about dynamic range manipulation and control. And of course, it's really wonderful, the information that is there. It's something that I have not discussed with you at that level, but of course we will talk about compression again, and you can be very sad about the fact that I'm going to talk about this topic for the third lecture together. But oh man, I think that we can talk about compression forever. I'm very happy that this will stay recorded there for us for the future, and that you can come back to this lecture and think about it and see it. Now, one more thing. Please note that the goal of this lecture is to get you to start using the technical ear trainer developed by Jason Corey. on the module of compression. So at the end of the lecture, I hope we will make a little jump to YouTube, and so you can hear better what I'm doing, and then we can assess how to use the technical trainer. I know that online lectures are hard to focus. That's why I hate to give them. But please, let's try to, I don't know, put some headphones, switch off your phone or something, and let's try to be together here. And if you have any questions or comments, just raise your hands right away, and let's try to make this as a team. And if I repeat something that I have already told you, please excuse me for that. I don't mean to be boring or repetitive, but it took me a decade to feel compression, and I still don't believe that I understand compression to the masterful level. When I talk masterful level, I'm talking about Michael Brauer, for example. Michael Brauer is a Grammy-winning engineer. I have mentioned to you about him. Very famous Grammy-winning engineer who he is kind of calibrating compressors attuned to the BPM of the song. Like, this is a man who understands like how a different compressor will work at a different BPM of the song, and none of us have this knowledge. And if we're going to have that knowledge, we need to see the scientific side of compression, and this is what we're going to do today. So there will be conversations about RMS, about peak again, but we have some great visualizations and everything. And the last disclaimer I would say is the very first time I deliver this lecture, so there are some things that maybe I will have to correct a little bit as I go, because it's a deep one. And yeah, let's go. Okay, so right, what we want when we are doing like a mix is that to have a great balance of the things that you're listening to, and so you need to control each one of the elements that you are trying to work with. When you record things with microphones, individual microphones, you have some control over the balance and the expression when you're recording at the recording stage, and then you're left with this material that is there for you to later on control, and you can do things with it by manipulating the dynamic range, obviously. And gonna follow here my line. You can always be writing the faders, like I was telling you, and you want to achieve a situation when you have a stable fader. That's kind of where we're trying to be. And then you have compressors and expanders, and we need to talk about expanders. And I think that I personally in my career overlooked expanders the majority of my career, and I know we have discussed this a little bit, but today we will go into the level of understanding really well. Like, well, I don't know if really well, but I'm gonna leave it there open for you so you guys can start interacting further with expanders. I want to insist. You know, I always wished that in the courses that I did, I would have a lecture like this about compression. Like, it's like when I will see everything finally and close these questions and see it more from a pro point of view. So let me just follow my logics here. Dynamic range controllers, so compressor expander, adjust levels automatically based on an audio signal level. Of course, that's okay. Yeah, we know this. Pop and rock music lead vocals, for example, have a super wide dynamic range. And so, I mean, we have this challenge, right? That's kind of what this beginning of this chapter tells us. Like, we have a challenge. The challenge is that when we're recording something, we can manipulate the dynamic range of things in the recording process by asking the singer to get away from the mic or by asking the drummer to play quieter. But once we have those recordings done, then we have a material that has a very widening dynamic range, and that's why we need these tools for, so we can find a static situation after in the mixing process. So you see, remember something, when I have told you, this is really interesting, when I have told you about the static fader idea, this idea comes from another engineer called Mike Senior. And now we're in the Jason Corey world. And in the middle of this Mike Senior world and Jason Corey world, you have Leo Perez there. There were three engineers, different engineers. And these three engineers are telling you the same. I'm telling you, in the process of my education, and I don't mean to glorify my work, but in the process of my education, nobody approached to these conversations like I am trying to approach it to you. Because everybody kind of was telling me their opinion. Nobody was sort of like justifying this opinion in some sort of literature or book or something. And now we have three people telling you what you want is to achieve the static fader situation. What do I mean by static fader? I told you already this a million times. A situation when the acoustic guitar plays and you don't feel that you want to touch that fader. If you don't take that advice seriously, That's your problem. I mean, we have 3 engineers telling you this. Like, and if you don't pay attention to this, that's kind of your problem. And I'm being an asshole again here. Oh my god, maybe it's today that it's my asshole day. But I'm just kidding. In the sense that we really want to find that stupid static fader situation. That's why we want our faders to stay in 0. And that's why we use compression. God damn it. Okay. So finding a satisfactory static fader with level without compression for a sound source as dynamic vocals is almost impossible, he's telling you. So when you have a singer and your singer is singing there, because I mean my goal is that you guys stop using compression like I don't know, like you know, when we fall and we kind of cover our face or something, it's like reflex, you know. I don't want you to use compression as a reflex. I want to use compression for a reason. And if you're going to use compression for a reason, it's going to take you an eternity, not an eternity, but a long time to sort of like feel this. And that's where we're going with all this set of lectures. And with the training that you will use. If you do this, guys, you will have a gigantic advantage over me. Like, I'm getting this now. If I would have gotten when I was your age, I would be so much more powerful in this moment. So he's trying to tell you something. We want to achieve an static fader situation, and if you don't, and for a vocals, for example, of a pop or rock song, if you don't have a compressor, it's almost going to be impossible because the range is so wild that it would be impossible. So use of compressor is helpful to get in getting part of the way to the goal of having a intelligible and musically satisfying levels. So you see, people tend to think like compression for fatness, compressions for I don't know, for beefing it up, things like that. Compression is to achieve a satisfying level of something. Consistent levels of instruments and vocals are good to communicate the ideas more efficiently. It's important to have a dynamic contrast. You see, I'm so happy that another engineer is telling you this. Like, I created this whole theory, which is like, hey, nobody tells you why manipulating the dynamic range is important. But the dynamic range manipulation is important so we can achieve emotion. And I told you this example of the screaming actor metaphor. I told you this many years ago. And by the way, a little commentary to those of you who are on the 3rd year. To those of you who are on the 3rd year must be maybe even more sickened than anybody else to hear again another lecture about compression. The thing, guys, is that when I made the foundation after you, I didn't touch compression so much as I touched when you guys were in the foundation. So the guys who are in year 3 maybe are even more justified to be tired of this topic. Because in the first foundation, I emphasized a lot on compression on the foundation. But in the second foundation, I didn't. Just in case, just so you know. Because I just remember that Grisha's compression of his head and how much we spent time doing that. We didn't do this in the second foundation because I already know. I already knew that there was going to be development of the technical ear and all of this jazz. So blah, 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 etc. Anyways, and let's continue. So the application of level control partly depends on the genre, with most classic recordings not benefiting from auxiliary control as much. So he's telling you something kind of like, you don't use compressor in classical music or in jazz so much. That's what that point means. If you don't hear this as every sentence is an advice, you should hear it as an advice. Now you know, you're going to mix some jazz and you say, I'm not going to touch that compressor. I don't want to touch that compressor. But yeah, most songs require dynamic range manipulations. Now, when you do this, of course, you will change the timbre of the instrument. So timbre changes between quiet and loud dynamic levels help you to maintain the perception of a dynamic range. Like, because we hear frequency dependent, when you start manipulating the dynamic range of a song, maybe some parts of the spectrum will become stressed out and you will be more hearable. Also because they were quieter. So that's natural that compression makes things harsher. It's because we are making frequencies that are a little bit quieter in your signal to be louder, and also the Fletcher and Munson curves explain us that we hear better those frequencies that are in the range of human voice. And so it's very obvious that, and I'm really happy that I'm able to explain you that, and I hope that you can feel it, you know, why a compressor is something harsh, because of the Fletcher and Munson. Because, I mean, it's kind of like making all on average louder, but I hear mostly the loudest frequencies that are in the human range, not because they are louder, but because my hearing device is designed for that. And that's what I was telling you yesterday, that I forgot that a human is who is mixing. And I really did, guys. I'm telling you, for a decade, I really forgot that it was a human, and I was seeing everything like as if I am a robot, that it's like receiving frequencies, and I am linear, you know. And it's so funny, like when the robots come to the Earth, they're gonna be shocked about our mixes. They're gonna be like, "What the fuck is that, man? Like, what are you listening to?" It's like, I'm a human, bro. Like, don't blame me for that. Obviously, when you take so far and you compress too much, you're gonna produce a situation when you have a lifeless recording. We call it like that, and it's really true. You can eat the life away if you compress too much. These are, you see, like, that's why I really wanted to make this lecture, and I couldn't end this year without this lecture. Like, look at this sentence here. Compression limiting are an example of nonlinear processing that offers means to sculpt and shape the audio signals in a unique and time-varying ways. Why I care about that sentence? So you understand that it's non-linear. What does it mean non-linear? That the more there is, the more... It's so stupid what I'm going to say. The more there is, the more there is. Oh my God! No, I mean, the more there is a lot. That's kind of what I mean. If it's linear, it's like, well, if you increase 1, you get 1. But if it's non-linear, if you increase 1, you get 3. So, you see, like, it's not true that if I compress 3 decibels and then I compress 6 decibels, I'm going to feel like it was double 3 decibels. You see, that's really fucked up. It's really interesting feeling. It's a really interesting idea. If I compress 6 decibels, it's not the same as saying I compressed twice 3 decibels. It's non-linear, so 6 decibels is more far away from 0, obviously, and it means that I'm going to get a harsher effect. And dynamic range control can help in the mixing process by smoothing out audio signals and adding cohesion, blah, blah, blah. That's okay. So, okay, look, guys, again, we are back in my favorite topic, which is this, like, a human is mixing. Dynamic processors work with objective audio signals measured in decibels. We don't work with objective audio signals. And that's a big problem. Like, we are operating compressors, thinking that compressors think like a human. I mean, I'm talking in a very abstract level. I mean, I don't think that we all think like that. But you see, like, if we start getting divorced from this idea, then that what I see in the meters is what's happening. That's so annoying, because I have told you forever, like, pay attention to the meters, and now I'm telling you, don't pay attention to the meters, and you're like, what the fuck, man? Like, what should we do? When I went to mix in Fly Sound, the 5.1 session of mixing, I made a very big mistake. It's a funny one. The very big mistake is that I was using a meter just to check out my levels, and I had the meter in the screen of the cinema. It was so cool. Like, I had in the huge screen of the cinema, I had the meter there on the top of the screen, and I was really not mixing only thinking about that meter. I just had it there. And what I'm telling you, that I made a big mistake. The big mistake was to leave it there, because when Sergey came, the headmaster of Fly Sound, came and looked at the meter, he said, like, aha, you're mixing only looking at the meter. You shouldn't be paying attention to the meter. You should be paying attention to your ears. And I was like, oh man, like, I was not mixing just using the meter. It was just there, but whatever. Anyways, so you see, we have a problem here. The problem is that compressors use objective signals and we don't. And that's an important factor to consider. And in the end, guys, you're going to see, I'm going to arrive in the end to a sentence that really blew my mind when I was writing it and I was thinking about it. The sentence is that because we have heard so much compressed music, we already don't know how uncompressed music sounds. And so we already don't know how the effect of a compressor sounds like, because everything we hear is compressed already, and we don't know how to separate this from our minds. And that's another challenge when we do compression. Anyways, now the decibel tries to correlate with how the human system works, trying to giving us a more measurements, like a I don't know, like a usable measurement scale, but still it's a human who is listening to. Decibels also scale the range of audio sound levels to a more manageable range. That's okay. We don't need to talk about decibels anymore. Peak level indicates highest amplitude of a signal. Well, RMS, here we're going to talk again one moment about peak and RMS, because I have a great material here to show you. It's some visualizations that are really good. So we refresh that. Look at this. Peak level indicates the highest amplitude of a signal at any given time. It's just the highest. It's kind of like how loud Leo speaks. Well, across his life, Leo spoke at 10 decibels, but when he played a Pobeda show, he was screaming, so the peak of Leo speaking was the Pobeda show, right? I'm gonna skip a little bit here. So for sine tones, okay, look at this. For sine tones, the RMS level is easily calculated because it will always be 3 dB below the peak level or 70.7% of the peak level. You will see this in this presentation, diagrammation that I have next. For more complex audio signals, such as music or speech, the RMS level must be measured directly from a signal and cannot be calculated by Karoche. Like the peak level, it's kind of calculated like this, just what was the loudest moment over time, and the RMS level is an average of it. We know this so very well. And there is something new, a new concept that I didn't know before, that is called the crest factor, which is the difference between the RMS and the peak. So just go in there. Now, look, for example, this is a really cool idea. Like a square wave has the same, this is a type of things that I wanted to discuss with you in this lecture. Like a square, and why are we talking about this? Because we want to understand how a compressor hears, how the detector of a compressor hears. You know, if we are working on a peak compressor, then the compressor is using this measurement to establish initiate the process of compression. But when we are in a square wave situation, for example, the compression doesn't understand the difference between RMS and peak. For example, these are the kind of things that I wanted to discuss in this lecture, like super final technicality, so we can leave this topic and I can sleep and think, fuck, I delivered some university quality material about compression to the guys, because it's such an important topic that it has to be done. So okay, we are seeing this, and we know like that our compressors can listen in RMS or peak, and now we can visualize a little bit that there are instances when these differences between RMS and peak get blurred and the system doesn't understand what the hell you want the system to do. So that's pretty cool. And if you shrink, you see, like for a square wave that is really fat, there is no difference between peak and RMS. But if you change the pulse width, there starts being a difference between peak and RMS. And so not all square waves are going to behave in this way, that they will trigger the compressor whether it is in RMS or in peak equally. And that depends on the pulse width of the actual waveform. And what is the implication of that? Well, most distorted guitars are square waves. Like most distorted guitars are square waves. And you see, there is not a coincidence, and I have told you in the past, I don't compress electric guitars anymore. And then I come and I find this information in the book, and I'm like, that's why I don't compress electric guitars anymore. You see, even I myself don't know these things, and that's why I assume that you don't, because I mean, I have been a bit longer in this earth. But that's the only reason. So you see, we start understanding, and the same is going to happen to synth. So maybe the next time you're going to compress a synth, you're like, is it squarey? Yes. Well, maybe I shouldn't compress it. I mean, there's not going to be compression happening at all, because there's no difference in dynamic range in a square wave, for example, and we're seeing it now. RMS can be thought of as a type of signal average, and the term RMS and average can be used interchangeably. So when you say RMS, you're saying average. Like, again, how loud Leo speaks. Well, Leo has playing a Pobeda show mode and playing and not playing a Pobeda show mode. Like if Leo is playing a Pobeda show, he speaks very loud. And if Leo doesn't play a Pobeda show, he speaks very loud. Anyways, I don't know if that is the case, but you get the point. Like my RMS will be the average of all my life. My peak will be the loudest scream I do with Pobeda. Now, what we're thinking right now in the area where we are is like how a compressor understands that it needs to start compressing. That's kind of where we are. Signal detection in dynamic processors. Loudness is used to describe the perceived level rather than the physical measured sound pressure level. We throw that sentence like water to you. Like we throw that sentence to water. Like you're like, yeah, loudness is not an objective measurement, it's a subjective measurement. And we kind of, again, that's why I was disconnected from the fact that a human is mixing. We kind of are disconnected from that sentence, but we need to always feel this, you know, loudness, it's not happening in the equipment. And the equipment, and you're trying to use an equipment so it makes the quieter things of something louder. And so obviously this is an equipment designed to manipulate loudness, yet the equipment doesn't experience loudness. You experience loudness. It's a very big problem. It's kind of like, I don't know, trying to get ChatGPT to speak a language that that it's not coded yet, and it doesn't exist in in code. And so how do we teach the system that? Well, perceived loudness is influenced by factors such as power spectrum and crest factor. Now remember, when we're talking, this is so cool, guys. You see, we're saying that this little difference between the average and the peak, that's the crest factor, and this is the formal way to address these issues. That's where the loudness lives, in between the difference between RMS and peak, which makes a lot of sense. It's like, how loud is something? You need to have a reference point. And so what's going to be your reference point? The average. And you see, like when we go back here and we read this sentence, perceived loudness is influenced by factors such as power spectrum, this is the Fletcher and Monson curves, and the crest factor, which is the difference between the RMS and the peak. Dynamic range compression increases the average level through a two-stage process involving gain reduction. I'm reading and then I'm explaining because this is very dense and I want to make sure I get it right. Dynamic range compression increases the average level through two-stage process involving gain reduction of the loudest peak levels, followed by a linear output gain. So that's a pretty dense sentence, and what it's trying to tell you is like, hey, look, a compressor, it's changing the average level of the whole thing and then turning it up linearly. Linearly. Not linearly was the detector. Linearly was the output gain. So what do you mean by linearly? Cool, guys. I'm so happy we're having this discussion. So sad that it's not happening in person though, but I'm so happy we're having this discussion. What does it mean linearly? It means one output, 1 decibel of compression, 1 decibel of gain boost. You see? If it will be not linear, it would be like 1 decibel of compression, 10 decibels of gain boost. And that's not how it works. So the system reads the average in a non-linear fashion. What is the meaning of that? That's complicated. It reads the average in a non-linear fashion means that it reads the average trying to emulate how the human hearing works. And then it outputs and it changes the output in a linear fashion, which means that it outputs 1 to 1. You know, if it was 1 decibel compression, 1 decibel of output gain. And compression limiting reduces the crest factor of an audio signal, making it possible to make an audio signal sound louder even if its peak level is unchanged. So what we change is the crest factor. We change, this is so cool, guys. I'm so happy. Sorry, I said it like for the second time in the last 30 seconds, but I'm just so happy because I get happy when I understand things. And I hope that in my process of understanding things, you also get to understand something. The compressor is changing the average level, not the peak. And so it's changing the average level. It's leaving the peak there untouched. It's changing the average level up. Let's read that again. Compression limiting reduce the crest factor of an audio signal. Remember, the crest factor is the separation between the peak and the RMS, making it possible to make an audio signal sound louder even if the peak level is unchanged. That's really important because sometimes we compress and we think you're making something quieter, but you're really not changing the peak level. You're changing the crest factor. Like you're kind of increasing the average and then lowering the whole thing down. I think that what I just said will not click to many of you right away, but if it does, it's a very powerful sentence. And maybe you can come back. I think that this lecture is a bit of a history in between us, and you will have to come back to this video again and watch it if you really want to get compression several times. Maybe read this chapter on the Jason Corey's book. Normalizing an audio signal would not necessarily make a recording sound significantly louder because engineers typically want to record audio signals so that the peak levels are as close as possible as 0 dBFS. Let me think about this sentence for a moment. Yeah, I'm actually gonna leave this sentence in red and I will think about it and I'll explain to you in another episode of our podcast. I want to be able to deliver that, and I don't have it so clear because I'm honest with you, sometimes I don't know very well what the process of normalization means. I need to see the mathematics and what it means. So I'm going to leave it in red. Compression limiting can still make a signal seem louder even if the peaks are already hitting 0 dBFS. This I understand. This I understand because we're raising the crest factor, we're shrinking the crest factor, we're getting the average closer to the peak. So I get why compression limiting can still make signal louder even if the peaks are already close to 0, because we're making everything that is under that threshold grow. It's important how to identify the artifacts. Of course, we need to understand how compressors change the signal and how how they manipulate this, how they can add artifacts. That's what I mean. But that's hard because we're used to hearing compressed signals only. So this is the moment when the author explains like attack time, release time, knee ratio. Of course, you know this. And I'm gonna be very fast here. I want to jump this quickly, but obviously when I was making this presentation, I was picking especially like the little things that I thought that could be new from this book that could help you and help me to understand things. So I'm sorry for the repetition, but I think it's worth going and watching a little bit here. Compressor and emitter are used to reduce dynamic range. They attenuate the level of a signal once it reaches a threshold level. That's nothing new. Compressor and expanders are adaptive sound processing effects that adjust the amount of processing based on the level of the signal or a secondary signal known as a sidechain king input. So this is an important sentence that we see it. Adaptative sound processing effects. So and this adaptative thing is not like adaptative in the range of 1 second. It's like every moment it's like analyzing what's going on and changing its behavior. So imagine that I'm trying to draw a straight line, but you have somebody moving my hand like all the time. So that's the reason why sometimes compressors can start making you feel that the signal is unstable or something if it's not well done, because the compressor is kind of like trying to do something always, and that's a useful thought to internalize and to feel. Yeah, I mean, now you heard this sentence. We talked a little bit about how compressors apply the RMS and peak principles to the detectors. So yeah, I mean, our processors are going to use either our processors are going to use either RMS or a peak level signal to decide what to do. Well, I mean, obviously we attenuate expanders, and this is really important. And I gotta be honest with you, I started using expanders on every mix this year. And that's a huge mistake of mine. How many mistakes I have made? I mean, this relationship that we have between us is like, it's kind of like when you guys were 5 years old and I was, what, the difference of age between us is like 13 years old or something, 13 years. Most of you guys are like 23 now, right? And I'm 38, so it means that I'm 15 years older. So when you guys were 5 years old and I was 15, you guys told me, hey man, let's do this. You go and make a lot of mistakes. And we will meet you in 15 years. And then you will tell us what were those mistakes so we don't make them anymore. So that sounds like a great deal between us. It's just like, it was a great deal for you. It's not a great deal for me because I had to suffer a lot in the process. But what I can tell you is like, if you start using expanders earlier than me in your mixes, you're gonna win. What the hell do you need an expander for? You need a compressor to make something quieter, louder. You need an expander to make something quieter. I leave it there. We will work on this later. And I know I have mentioned it already, but I know how stupid our brains are to understand compression. We need to repeat these things 10 million times so we get them. So remember these words. If you don't mix with expanders, now you are being like Leo, making a mistake. You can make that mistake for a year. Don't make it for 15 years. Okay? That would help you. Different compressor limiters have their own unique sound based on factors. We have discussed this a lot, like how the detector works, the slopes, and everything. Compression parameters typically include threshold, radio, attack time rate. Nothing new there. A compressor starts to reduce gain of an input signal as soon as the amplitude of the signal itself or sidechain input goes over the threshold. I'm not going to read this because it's so basic for us. I'm just focusing on the things that I think that are new to us. This is a quote from the book, so let me read it. The amount of reduction applied depends on the ratio. Yeah, there's nothing new here in practice. The attack time can help an engineer define. Okay, this is a cool thing. If I would have understood this 10 years ago, it would have made my life easier too. The attack time can help an engineer define or round off the attack of a percussive element or the beginning of a musical note. Yeah, nothing new here. Release time. Let me read about the release time. I want to move here. If there is anything new we can take from here. Versus of applying gain reduction. Yeah, no problem. This is like I mean, these little technicalities and words and how he puts it. It's very important for us to sort of like print in our brains, because we're not in some summer course. We are trying to be academics in a way of this topic. So we need to talk about these things in the proper language. The release time is the time it takes for a compressor to stop applying gain reduction after the audio signal has gone below the threshold. Maybe you knew this, maybe you don't. That's the correct wording to use. As soon as the signal falls below the threshold, the compressor begins to return to its unity gain, and it reaches the unity gain in the amount of time specified by the release time. Unity gain means how it was before the process started. So signal cross the threshold, signal cross the threshold again. Compressor wants to stop acting. Should it do it right now or should it wait for a little bit? And the same happens the opposite way. The signal cross the threshold, the compressor wants to start working. Should it start working right now or a little bit later? Depends on the attack and release times. No questions. Knee, we discussed the knee so much, I'm not even gonna, well, I mean, I'm gonna read because maybe there is something interesting here. The transition of level control from below the threshold, no gain reduction, to above the threshold. You see, that's super technical way of saying it. The knee describes the transition level control from below the threshold, no gain reduction, to above the threshold, gain reduction. A smooth transition from one to the other is called a soft knee. We know this. Ratio, we don't need to talk about this, I think. Let me see if there is anything interesting here. Let me just fix this. This is copy from the book, like direct quote from the book. The compression ratio determines the amount of gain reduction applied once the signal raises above the threshold. If the ratio of the input level, well, for instance, to 1, yeah, okay. I'm not going to talk about this anymore. Level detection timing. Dynamic processor needs to determine the amplitude of an audio signal to compare it to the threshold set by an engineer. I'm going to process this and then I'll tell you what I think is useful from here. Different methods can be used to measure the amplitude of a signal. Yes, that's all clear. Peak detectors. Yeah, this is all clear. Like, I mean, we use, remember when we're going to compress something that it's percussive, we don't use an RMS. This is nothing new. When we're going to compress something that is non-percussive, we use a RMS, and that's nothing new. You see, there are some compressors. I didn't know this, for example. There are some compressors. This is a case of a device called the GML 8900. It's a dynamic range controller that has a fast and slow RMS detector system. So there are some systems that have a faster RMS system. That's cool to know. Yeah, this is all clear. Nothing new here. When a compressor uses slow RMS detection, it cannot effectively respond to very short transients. That's all clear. Steep transients have left influence on the average signal level than RMS detection. This is all clear. Nothing new here. Now, we go into a very cool moment. And if our attention is a little bit scattered right now and not clear, zoom in to me for a moment because we're going to see something really cool. This part of the chapter is trying to visualize the output of a compressor. How does it looks like? Like, can I see? I don't want to hear. Can I see how it looks like when a compressor is working? And again, if your attention is not with me, please give it to me because it's going to be a cool one. So, to fully understand the effects of dynamic processing, it's important to visualize how a compressor output changes over time. So, we need to understand how the output of a compressor changes as time goes on. They are non-linear time-varying device because they change the gain of an audio signal over time. We discussed this a couple of minutes ago. Compressing the sum of two signals generally produces a different result compared to compressing the two signals individually and then adding them together. Aha! This is so important, guys. These are considerations before we go and see some visualizations. This is obviously so important, and it has gigantic consequences for your mixing and everything, and this sentence, it's very important. If you grab two signals and sum them together and compress them, that is going to produce a different effect than if you compress each signal individually. That's super obvious, but at the same time it's not. And I'm saying it strongly so you guys in the future consider this, okay? To observe the effect of a compressor on an audio signal, a steep function is used as the input signal. So I am going to paint this in red and think about this a bit more so I can come back to you. These are quotes from the book, so that's why there are some sentences that maybe I haven't processed fully. As I told you, it's the first time I give this presentation, so I'm going to put it in red and I'll discuss them with you in the next lecture, just so I don't spend so much time. Yeah, and I think the same is going to be with this one, a steep function. I mean, I just need to understand better what is the steep function, and I will process this a little bit later. Allows for illustrating how compressor responds. Yeah, I think that the steep function is going to be connected to these visualizations that I'm going to show you right off the bat. So we're going to try to see, how amplitude modulated sine wave with a square wave modulator and a peak amplitude switching between 1 and 0.25 acts as steep functions for the visualization. So yeah, the steep function is I mean, it's a way, we are applying a certain amount of compression to a sine wave so we can visualize what the hell is going on. And I'm writing here, this was my joke there, like no sine waves were harmed during this experiment. So check this out here. Check this out here. This was the signal, how it was. Imagine it like a sine wave, like, and then like some sort of like decay, release. You see like function signal after it, like. So the first one is how the signal was originally. Now look at this, a long attack and release times. Like this is how it looks like when you have a long attack and a long release. So let's think about it for a second. And this moment is so important in our relationship, guys. Like, because this is the moment when we're gonna start feeling these things, I hope. And if you don't, come back and see it again and meditate about it again. So check this out. Imagine a long attack and release time. So the signal starts, this is how it was originally, you see, and I achieve something kind of like this. Why? Because the attack is slowly happening over time. And then look at the release coming up, like up and letting it out until we go back to this background average level that we had here. You see, that's the release, and here we are visualizing the attack. Now you're visualizing a medium attack and release. So you see I think this is the moment when you let the key go. You see? Imagine something like, and then you let the key go, and there is a little bit of sustain after. That's my interpretation of this. You understand? And it's done on purpose so you can visualize it. So you can visualize the release. They want you to visualize the release. You see, like that's what I interpreted. It's like, and that's what I think it means by this, like a step function. It's a very, like, I don't know, in my interpretation, I may be wrong, I will research that, but I think it's a very technical way of describing the situation that we find ourselves in right now here. So there you go. Look at the long attack and look at the medium attack. You see, in the medium attack, the attack is a little bit faster, so the compression happens a bit faster than here, and the release happens a bit faster. And then you have short attack. You see, like, only the transient, it's allowed, and then pop, everything. And now, fuck yeah, man, this is, maybe I could just, all our Moscow Music School lectures could have been this slide and then good night, and then I go to rest and you guys just watch this slide and that's all. Like, because it's so important. So you see, remember that in audio and in music, I have told you this a million times, everything is about the relationship between two things. So the effect of something like this, even though, you see, and this is what I meant above when I was telling you, the loudness, perceived loudness of something can change, even though the peak level doesn't changes. Because again, if we don't forget that there is a human mixing, and we remember that there is a human mixing, you see, the human will hear this, and what it will interpret it is, say, the first transient, please, I'm now talking about the last box here, the very last box. A human will hear this and interpret it like, the first transient was louder than everything else. No, it was not louder. I mean, it was louder, but it was the same as it was before compression. But we will hear it louder. And if you get this, you will understand how important it is to not forget that there is a human mixing. Because the device will not see it in the same way. I don't know if I'm making myself clear there, but I feel this and I'm really shocked about this sentence. So, going through this again, no compression, you see the signal up and then having some sort of decay there. Long attack, you see the amplitude of the signal falling slowly. So what would be the effect of the sounding of that? I mean, it would be that we will hear that first, I'm calling it a transient. I don't know if we should call it a transient. But basically, let's call it a transient for now. It's easier for us to call it a transient. You can think that this is like a bass sound, like a kick drum, like, and then that it has a little tail. The more we're going down to a faster attack, the more we are feeling that the transient is louder. Even though the peak never changed, god damn it, that's so crazy. The peak never fucking changed. But in any ways, we perceive it louder. Because we made something else quieter. Our brains are so crazy. We made something else quieter, so now we think that this is louder. Like, okay, anyways. That's where we are in these slides. That's really cool. And we know this. I know you know this. But now you see it, and maybe it can help you to see it. So, what we have here, attack and release curves of different compressors may vary. So this is the same. This is interesting. Wait, let me process this 1 second. Attack and release curves of different compressors may slightly vary in shape. This figure 4.1, where there is an overshoot in the gain reduction during the attack phase. Yeah, I mean, basically, some, for example, some compressors can react like this, in the sense that. Wait, let me try to process this a little bit. The same modulated 40 Hz sine tone through a commercially available analog compressor with attack time approximately that okay. But the first one is not. It's not. I guess that this is. Let me see something. Attack time 50 milliseconds. Let me see it. They don't show me here the attack time. Here. Wait. I'm trying to see, like, this comparison. I mean, I think that this guy is trying to compare to us something like this medium attack release times. Like some compressor can do it like this. I think that for the purpose of my explanation, it kind of doesn't matter what exactly are the parameters. I want you to feel this. Some compressor, imagine that you have a medium attack and medium release times. Some compressors will do it like this, and some compressors will do it like this. You see? Up, and then it grows again. Like, so it's kind of like overdoes it, and then goes back to its usual trajectory. So that's not, I mean, you are visualizing there, seeing what can be something that makes a compressor sound different than the others. Is that after the attack time happens, it kind of compresses a little bit more maybe than the ratio that you chose. You know, it kind of like overdoes it. That's what it means, overshoot. In the gain reduction during the attack and phase before settling into a constant level. You see? Like some, and maybe that's why they pump. You see, because it's kind of like they overdo it and then go back to, they try to go back to where they should be. And that's connected to the compressor design. Maybe that's something that the compressor designer wanted to achieve. So here we have another diagrammation. Let me process this a little bit. Presents an example of an audio signal processed by a compressor showing the result gain or the resulting gain function derived by the compressor based on the input signal level and the compressor parameter settings. The gain function indicates the amount of gain. Yeah, this is how the compressor of Ableton looks like, and it's just kind of showing us what we are used to seeing already. Wait, the gain function derived from compressor parameters. The resulting audio signal output on the bottom from the compressor is the input signal. I think it's this guy is just trying to show us how it looks when you use a sidechain as a part of the compressor process, and it just looks like this. I mean, you're using a signal to push the other one, and then this is the resulting output from here, basically. So let's move on. Okay, let me think about this for a moment. Wait, this is where I was last night? Yeah, it's okay. We're not so far away. You see, like, these are just like closing remarks on compression. Now, he's kind of trying to tell us here something. It's like, okay, look, dynamic range compression can be challenging for beginners to understand and use effectively. Compression is often meant to be transparent, meaning it shouldn't be noticeable. That's an important thing. I'm going to put it in purple here. Compression is meant to be transparent. It shouldn't be noticeable. I mean, so we know that when we're compressing, when we start noticing it, is maybe that we're overdoing it. Engineers use compression to fix volume inconsistency in instruments or voices. The degree of compression can vary from subtle to obvious depending on the settings used. Obviously. I mean, depending on how you compress, you're going to be doing too much compression, too little compression. That can be useful, artistic or not. We use this a lot. This is what I was telling you before. So we're used to hearing compressed sounds. When we hear acoustic music without compression, it can help us understand what music sounds like in its natural state. What he means by that is that in order for us to understand compression better, we should be listening to things that are not compressed so we can get used to again of how uncompressed things sounds, because right now sometimes we apply a compressor and we don't hear it, we don't understand what's going on because we're so used to it. And I don't know, I think that's a good point. Like the signal can be difficult to hear because it blends with the original sound. Yeah, this is really important. So I mean, he's kind of trying to tell you also that, remember what I said a couple of minutes ago, that I was saying, like, imagine I'm trying to draw a line and then something is trying to move my hand as I draw the line, you know, and so it's like changing over time a lot. Compressors are changing over time a lot. And so sometimes the dynamic range of the signal changes. And the compressor is trying to adapt to the dynamic range of the signal changing. You see, because the compressor is acting in every single given moment. And then it's like, and it's correcting for this. So that means that sometimes the dynamic range change of the signal, it's confused as something that the compressor is doing. It's a very stupid sentence. It's not so, I mean, I think it's important, but it's not so like life-changing. But what I'm trying to tell is, like, it's natural that you cannot understand what a compressor is doing sometimes. Because maybe what's happening is that you're listening to the natural variations of dynamic range of the signal. If a modulation is not synchronized with the audio signal, this is really important, guys. And I will tell you what that means in a second. This is so freaking important. And it's so freaking important, yeah. If a modulation is synchronized with the audio signal, it becomes more apparent as a separate event. For example, a sine wave modulation is easily heard because it's not synchronized with any acoustic instruments of sound. What it means is that you need to have a good relationships between your attack and release times and the natural flow of your dynamics, of the dynamics of your sound. Like, for example, when you are compressing, this is what I mean. You remember once I told you, like, hey, when the release of the compressor needs to happen before the next hit happens, so we have some sort of like coherent compression, that the compression is not happening when the next hit is happening. So, and that makes you hear that compression is going on. You want to hide that compression is going on. So the rate of your modulation, because you can see compressor is a modulation. It's a modulation of the attack release of the envelope of the signal. So if it's not synchronized with the audio signal in the VPN, it's going to be identified as a separate event. So you will start identifying that it's happening. Compression can introduce artifacts which are unintended. Maybe it's not what you wanted. However, in some cases, these artifacts are intentional and contribute to the desired sound. Like when you destroy some drums and compress them really hard. Engineers need to understand these artifacts and decide how much compression to apply. Great. Dynamic range controller respond to... Wait. Loudness, this can sometimes reducing the level more than... Yes, and this is another thing that I mean when I say that a human is mixing and not a machine. Dynamic range controllers respond to objective measurements of a signal level like peak or MS, but we live in the subjective loudness world, and this can mean that sometimes we overcompress something, or maybe compress it a little bit, but to us it sounds like a lot of compression. This results in a compressor reducing the level more than desired due to differences between objective and subjective perception. That's important to keep in mind. Wait, I see a mistake here. This is not from here. This is from the source of audio production. Yeah, let me just put this in the right place. Boom, boom. Okay. And then there is, when mixing and multi-track recording, engineers focus on adjusting the level, dynamics, and balance of each track. The aim is to avoid sound sources getting masked by others. Spoiler alert to the engineers. Like I told you yesterday, I'm rewriting all of my mixing courses, kind of like, I mean, not rewriting because I don't have the mental energy to rewrite anything. I'm so tired. I just may be moving things around, but masking is going to be almost like 40% of our mixing course next year is going to be about masking, and we will talk so much about it. What this means is that you are turning down and up signals in volume as the mixes progresses to make sure that one of them doesn't obscure the other, and you use compressors to achieve that. Engineers try to find the best musical balance by adjusting levels across each note. A phrase of music is a compromise because not every note can be perfectly clear. Basically, I mean, like the difference between these two slides here, it's like one is trying to tell me what happens when I do automation and let the compressor do its own thing across the whole song, and what happens if I start like manually manipulate the parameters of the compressor on each moment of the song, like by either making automation. So basically, in the first case, you leave the compressor running in the whole song. In the second case, you do automation, like specifically. Engineers try to find, yeah, here's where we go. It's a compromise because the every note can be perfectly clear, even with extensive number range control. So I mean, you're sometimes are gonna have to automate the compressor so it compensates for different moments in the different songs, obviously. And that's something that I also started doing very late in my career that you can do earlier. You know, put your threshold level in the automation line. Put your ratio in the automation line, and just like apply less or more compression depending if you want to increase the average of the signal or not. Prioritizing is important in balancing the mix. For example, vocals are typically more for them, and that's really clear. Compression can help make the performance more consistent in volume. I mean, yeah, nothing new there. This is his opinion. It's like, hey, you can use like this in vocals to make sure that everything, like, kind of nothing stands out above it. That's really clear. And you can automate that as well. Lever control or on individual sound sources allow engineers to guide the listener's attention, dynamically emphasizing or de-emphasizing instrumental vocals. I mean, these 2 points are kind of like, hey, you use this to achieve a static fader level. For that, maybe you're going to need some automation sometimes, but in general, a compressor is for that aim. Yeah, you do automation so there is not so heavy artifacts and people don't get shocked about your level of compression. When you do compression, obviously you create some timbral changes, like you change the timbre of things, because we listen frequency dependent. If I make, imagine that a sound evolves over time and then it has a moment in which 3K was very prominent, but because the attack of the compressor is coinciding with that 3K moment, I'm turning down that 3K. And I'm not turning down the moment that was preceding it, that was not 3K, but was like 500 hertz or something. I don't know, imagine a synth, like it starts in 500 hertz, then it goes very wild in 3K, and the compression happens to the 3K moment, not the 500 hertz moment. So I will experience a change in timbre. So you see, I hope that you felt what I just said, because it's really important. Compressors not only change the envelope, but also change the timbre, because humans react differently to different frequencies, and those frequencies happen over time, and there is a moment when those frequencies get compressed or reduced in value, and then we hear that timbre differently. When compression is applied to a mix, it helps different elements to blend together, creating a cohesive sound. That's another point. I mean, like because you're increasing the average when you're compressing, this kind of like gives you the sense of gluing something together. Compressors can make the elements of a mix sound connected because their amplitudes change in a similar way. Yeah, I mean, you see, like we're changing the difference between the peak and the RMS value, sort of. And so we're doing this for the whole mix. And this produces this situation in which we feel that those elements are more connected and more glued together. That's why we use that word. If multiple instruments in a mix have synchronized changes in volumes, our ear perceives them as focused together, resulting in a more cohesive mix. So what this means, this is really cool, and this is really important. What this means is that, imagine that I have a snare that becomes louder, and then after that a bass line becomes louder, and our brains are like, louder, louder. Our brains likes to hear something like they both became louder at the same time. And that's why compression helps us to glue the songs. I hope that you felt that. That's really important. I repeat, imagine, kick became louder, and then 2 milliseconds later, vodka became louder, and our brains are kind of like, But if they both become louder at the same time, so our brain is like, oh, like what the hell happened there? And that's why we feel this glue. I will read this again. If multiple instruments in a mix have synchronized changes in volume, our ears perceive them as fused together, resulting in a more cohesive mix. And now you can articulate why a compressor glues the mix. A compressor glues the mix because it makes separate elements to increase in loudness or decrease in loudness simultaneously. And so that gives us the sensation that this is more cohesive. That is one element. Fuck, that's really cool. That's really cool. It landed on me, this sentence now. And I will say it for the 3rd time. We feel that a mix gets glued because each element either increase or decrease in value, in level simultaneously. That's really cool. It's kind of like watching one dancer alone dancing in this coordination with another dancer, and so you don't feel that the whole performance is one. You see like two performances. But if they act in coordination, then you feel that it's one performance. Our brains tend to do this. Then he's trying to tell us, like, we're almost close to the end, by the way. Then he's trying to tell us, like, hey, what is the effect of a attack time? What is the effect of the release time? If a compressor has a long attack time, around 100 milliseconds, low threshold, high ratio, we can hear the sound decrease in volume when it exceeds the threshold. This effect is known as pumping. So let's read this again. Compressor has a long attack, low threshold, and high ratio. We hear the sound decrease in volume. It's like, ooh, like we saw that it's like this case, ooh, right? And that's what we call pumping. Yeah, however, sounds that have more consistent volume, like a distorted electric guitar, because it is a freaking square wave, right? And now we know this, we will not feel that pumping effect because there is no difference between the peak and RMS value that the compressor can exploit. Effects of the release time. When a compressor has a long release time, we can hear the sound return to its original volume after significant volume reduction. Like it's kind of like breathing. This is called breathing. You see, pumping is slow attack, so it's kind of like ooh, and breathing is more like ooh, right? Something like that. Like it was quiet and we hear it returning to its level again. Then the next moment, maybe I'm gonna make a bit of a jump in here. Wait, let me see this. Let me think about this for a second. I had drums, the expander. Wow. I think I made a mistake here in my presentation. Yes, I did. I kind of like summarized some stuff, but I didn't put it here. So I'm gonna move this till the end, and then we will discuss this later in a future lecture. Maybe not, because we have discussed so much this, but it's kind of like some in the book there was like a moment when he was discussing drums and compression, vocals and compression, guitars and compression, and I did all of this, but I don't know what happened. I kind of like lost it in some of my slides or something. I need to check it, and I don't want to miss time. I want to continue because I want to get to the technical ear trainer. So we were here, and then there is a conversation about audio expanders for a moment. I didn't want to leave this out of the conversation because it took me 15 years to start using them, so I don't want you to take 15 years to start using them. So I wanted to talk one moment about expanders again for the last time. So it is possible to use compression in a way that emphasizes the contrast between the short and the strong peaks and the quieter and sustained sounds. So compression gives us an effect of a dynamic range. In this sense, compression can create an effect similar to dynamic range expansion by highlighting the peaks relative to the following quieter sounds. So I articulate this better a couple of minutes ago than what is written there. Our compressors are grabbing quiet parts and making them louder. Our expanders are grabbing quieter sounds and making them quieter. And so when that happens, obviously, I'm also increasing the dynamic range, right? But I am emphasizing the transient, for example. Great use case, overheads and snares. You know, you have an overhead and you have the hi-hat. You want the hi-hat to be quieter than the snare. You use an expander. I remember mentioning this to you. I apologize again. Not apologize, but I mean, I'm conscious of these repetitions, but it's the only way to make these points land properly. An audio expander is a dynamic process tool used in audio engineering to control the dynamic range of a sound signal. Its primary function is to increase the volume or level of quieter sounds of signals while leaving louder sounds unaffected. Or you can just do it as well in the opposite way. When audio signal exceeds the threshold, the expander reduces its level by the specified ratio. So that's the important thing. Audio signal exceeds the threshold, then the expander reduces its level by the specified ratio. It doesn't augment it. This effect lowers the volume of any accompanying noise or background signals, making the desired audio stand out more prominently. So, great. Audio expanders are used to improve the quality of recording or to reinforce clarity of live performance. I left you here a video explaining like how to use an expander. I will not discuss this so much anymore, but don't ignore expander's role in the dynamic range processing. So how to practice? We go to the technical ear trainer. So we have now the dynamic compression and dynamic expansion module. So this is the moment where maybe, I don't know if it's necessary to jump to YouTube. Obviously, you know what's going to happen. I'm going to put you in Google Classroom, an evaluation, which will be some technical ear trainer time with the dynamics compression module. So across this course, we did the parametric equalization, the reverberation, and dynamics compression. And I think that we will even get out all to the distortion. And that would be really nice completation of the development of the technical ear. And you will have like these two summative, which will be the distortion and the dynamic range. Right now, I will put the dynamic range only because it's the only one we have. What's the name? That we have explored. So just what I have here is like the just like always when I introduce anything on the technical ear trainer, I put you here like some explanation of what's going on. So you have so the dynamic modules give you practice on attack time, release time, and ratio. Practice can be done with each parameter individually. You can do it like, I mean, only attack time, only the same as always, like, but it's just applied to compressor. Threshold, which controls the level of compression occurs, is adjustable. In the compression module, it's recommended to initially set a low threshold, make a gain. I mean, these are some instructions on how to use it. And then you have the options and parameters, like always, like, you know, attack time, release time here, the level of difficulty. And we can do matching memory or absolute ID. This is explained here. Yeah, the same as always. And yeah, and let's go to the TED 1 second and see what we can do here. I think maybe I have to open this in a new... wait. Just a second. No, I don't have a sound here. Ah, because it's waiting for sound. Bypass question. So wait. Just a moment. So this is a question. Just a moment, guys. Practice reset counter. Yeah, I guess that it's gonna be easier to identify with a sound file. Let me just load a sound file here. Any sound file. See if I can find something quickly. Okay, wait. Yeah, I guess that this would be okay. Let me try to do it with a sound file to see if it's more clear. So let's go here, sound file, and move this here. Just a moment. Yeah, this is so hard, guys. This is so cool. Okay, so wait, I want to... So I want to understand the attack time. Wow, it's so hard, guys. It's so freaking hard. Let me check the first one. It was 25 milliseconds. Dude, this is gonna be so hard, man. 25 milliseconds, release time was 50 milliseconds, and the ratio was 5:1. Let's go to the next question. And you can change the threshold, I mean, to increase the level of compression or not. Because what you're really trying to understand is the attack time and the release time and the ratio. So I think that this is a... Oh shit, man, this is gonna be so hard. I'm so happy we're doing this, guys. This is so hard, man. I'm gonna turn it up because I don't hear. Ah, you guys don't listen what I'm doing, right? I see, I see. Yeah, let me move. I think I have to move to another browser. I have had this problem before. Let me go to Safari, 1 second. This is gonna be really hard, guys. I mean, you're gonna have to, I hope that this is gonna help us to improve a lot our understanding of compression, but you're gonna have to learn by getting your answers wrong and then comparing, because it's so hard to understand this for us out of the bat. Like, I think it's not the same as in the other cases where it was so listenable, hearable. Wait, but if we do this, it's gonna be obviously a mega plus for us. I wanted to see in loopback if I got Safari there. Yes. No, this is QuickTime. Well, where is Safari? Yeah, there it is. So do you guys hear the audio? Do you guys hear the audio from... Huh? No? Wait. Let me check this. Wait, I think I know why. Wait. Ah, sorry. I'm stupid. I'm back here in... Back here. Let me go back to Safari and then try... Yeah, sorry. Now you will hear, I think. Yeah. So, oh my god. So, okay, so I think that the best way to start here is like looking at the amount of gain reduction that is happening. Like, at least, because we have to guess 3 parameters. We have to guess the ratio, the release time, and wait, let me check the answers. Wait, no. You see, like, because we are in attack time, he's always in release 50, ratio 5.1. Let me see. Yeah, you see, like, it never changes. Release 50. If the only thing that is changing is the attack time, so that's cool. Like, we know that it's 50 milliseconds and 5.1, so we need to focus on the attack time. So here's my response. I'm gonna change the makeup gain. Okay, the makeup gain, you see, it applies to both of them. So we can hear. Okay, focus on the attack of the kick, for example. The actual beater of the kick, and you will see that it has to be that my attack time is faster than the one that is in the example, because I hear the attack of the kick quieter in my case than in the example, and the attack time, you know, it will shrink the size of that beater. Look, this is my question. Let's go back here. I can understand that maybe those of you who are not on YouTube, who are on Google Meet, maybe will not hear this nuance so clearly, but I can hear it here. I'm gonna go for that. Ah, it was 100. It's gonna be hard. This is gonna be so hard. That's cool. You have only 3 steps, so that's great that we can try to identify the difference between 2 milliseconds, 25 milliseconds, and 100. So let's go to the next one. I'm gonna go for 25 there. No, it was 100 again. This is gonna be so hard for everybody. starting like this for everybody. It's so hard. Let's go back here. So you get the point. I mean, and then we can change the release time and understand the release time. And then the and then the attack and release time and etc. I mean, it seems like it's me who has to be the first one who does this dynamic ear range compression. I have never done ear training on like this. So I myself, I'm going to do it as well. So we did it. I'm very happy for the results. I'm very happy we did this. And I will move on from the dynamic range topic kind of forever. I mean, we will not discuss it at this level anymore. And I hope that this was a little bit of like 2 more cents in our understanding of compression, and that it can help you to visualize the future and to make better mixes and better sounding records in the future. At these points that I left in red, I will kind of like research them, and next lecture I'll catch you and I'll discuss. What comes next is saturation and also multiband processing and etc. Like on this development of the technical ears course, and of course it's all connected with mixing and mastering and all of that. So I will put you the task of doing the technical ear training on compression in the same way we did it always, but for compression. And yeah, do you have any questions or comments or ideas, feelings? Yeah, of course. Okay, thanks for asking for that. You mean as a mixing resource, yeah? Okay, excellent, excellent. So I will... Yes. I will make a note on that, and when we talk about saturation, I will display like the usage of 3 separate tape machine plugins. And you will see that they all have the same parameters like always, and I will explain you what those parameters are. I'll build some slides about imina tape machines because they're so important and we use them a lot. So thanks. When you guys ask me things, that helps the course to become better. So thank you very much, Grisha. I will do it. Anything else, guys? So, Grisha, now officially we will not be shrinking your head anymore. Hooray, because it's the end of our conversations about compression forever. Fortunately. So, I don't think that this is like enough to cover this topic. I have said everything that I can say about this, but now it's up to you to just go and practice and think about this, and just to stop using compressors just like I don't know, like some sort of like we shouldn't be using compressors like we use tape machines, you see? And what I mean by that, like we shouldn't be using compressors to add harmonics. Like we should be using compressors to achieve a stable fader. And if I achieve that goal, that you guys understand that and use it like that way, I would have made a good job. So anyways, gotta go to work on this stuff that I'm doing. To the 3rd year guys, see you at 2 p.m. I'll be here. To those of you who are in the school, I'm sorry that we did this online. You helped me a little bit there. Next week I'll be there with you physically and we continue our journey. Remember, I will make an approach now. The approach will not be about if the show is gonna be in the end of June or not. It's gonna be like, do you want to play in Moscow Music School Festival in August or before August in a smaller show? And then you answer, and based on that, we will build a great show together. Okay? And the second thing is like, yeah, with me, there will be lectures until June 23rd. My last lecture is around June 24th or something, just so you know. So if you have plans, it's better to plan if you're going to go on holidays. Da. Well, actually, I mean, to be honest, on the 23rd of June, there would be not one lecture with me. The last lecture that would happen with me is on the 22nd, but it depends on so many factors. So I'm saying that date as an orientation. But anyways, thanks for letting me know. Do you all have YG on that day or? On May 23rd. Yeah, like, I mean, I see. I had put here, yeah, I had put on an activity on May 23rd, but I'll put it on May 24th then on Saturday. Like you're thinking. Yeah, that was a mistake. I mean June. Sorry, I mean June. So I'm gonna put that. I had an activity of the mixing and mastering. I want to mix and master a little bit on DTH, and we will do that on the 24th of June, not on the 20th of June. Yeah, 24th of June, not on the 23rd. Because you guys have the guess, so I'm gonna move it right now so I don't fuck it up. Okay, thank you guys. So I'm gonna sign off for now. Thank you very much. I hope it was useful, and I hope to see you soon. And have a great day. Bye bye. See you a bit later. Bye, Sebastian. Thank you. Thank you for being here.